Underwater construction poses serious risks to human divers, making robotic automation a practical alternative. But automation is difficult. Poor visibility and fluid dynamics complicate localization and precise placement. To operate reliably under uncertainty, we need to create construction techniques that tolerate misalignment. To address these challenges, we introduce URCHIN, a modular interlocking block system with a self-aligning magnetic interface and a localization-ready design. URCHIN voxels contain a radially symmetric configuration of nodes, each with a neodymium magnet and interlocking geometry to resist shear. Legs are sized to be grabbed using general-purpose robotic manipulators. Voxels are manufactured using primarily 3D printed parts with hexagonal metal rods for structural rigidity. URCHIN voxels snap together reliably, even with up to 4.4 centimeters of misalignment. Magnetic forces guide alignment, enabling robust connections without precision placement. We tested structural load capacity underwater using a pulley-based rig. These results aligned closely with our proposed analytical models. Using a Reach Robotics alpha arm, we were able to autonomously assemble URCHIN voxels into complex structures, even under positional uncertainty. The uniform symmetric nature of voxels means that they can be assembled from all directions, allowing for increased freedom in the kinds of structures one can build. We believe that URCHIN is a crucial step towards autonomous underwater construction. Future work includes mechanical interlocks and advanced planning algorithms. Thanks for watching.